Point platform gateway, flex gateway, spike control policy, request timelines. Here, request timelines in spike control policy in flex gateway in Anypoint platform gateway. The spike control policy uses a sliding window algorithm which reduces the spike in traffic and protect the gateway instance. The window self-adjusts its display size to accommodate the results over time. If the current window has no remaining request quota without closing the connection to the client, the spike control policy allows the request to be queued for processing later. For your policy to queue the request, you must configure the policy parameters as shown in the following example here. The time period 1 second, number of requests 2, delay time in milliseconds 499 milliseconds, delay attempts 1, queuing limits 5. Queuing a request requires remaining a thread and HTTP connection. When you specify queuing limit for the policy, the parameter protects the gateway from running out of resources and ensures that the API does not fail in case of an attack. Request time limits, timelines. The following diagram illustrates the lifespan of each request accepted by the algorithm using the configuration defined before. The first requests are accepted. The first two requests are accepted and available quota is now 0. The quota increases to 1 after 1 second. The window size value passes from the request 1. Request number 3 arrives. Because no quota is available, the request is queued for 499 milliseconds. 3, the request 4 arrives. Number 4 arrives. Because there is still no quota available, the request is queued for 499 milliseconds. Shortly before request 3 is retrieved, the request 1 ages a second and the quota is released because it fails out of the window. 5, the quota is now 1. The request 3 is reprocessed successfully. The quota returns to 0 until request 2 ages quota returns to 0 until the request 2 ages 1 second. The request 4 delay conclude it and it must be reprocessed. Request 4 is rejected. Request 2 and 3 have not aged a second. And there is no quota available. The request 4 have no more delays. The request 5 arrives because the request 2 has already aged more than a second. The request is accepted. In this example illustrates the request delays and how queuing regulates spikes in the traffic. In high connection scenarios, the backend continues to function properly. It serves no more than X request and in the last Y milliseconds. User querying the API might still see their request being served, but with the higher latency. Exact configuration for policy depends exclusively on your API and its throughput. Here you can see the time here, and here you can see the time period, and here the accepted request here, and here the rejected request, and here the queued request, and the queued request 3 is accepted request, and here the queued request 4 is a rejected request. Here now this is the end of my presentation. Thank you very much for watching it.